Adi, I am Pakistani and much Mr. Pakistan. So today this video I will teach you how we can make an analog thermometer, aka analog temperature sensor using analog thermistor and type anti-feed thermistor module plus 7 display using without 7hc595 IC. Because in my days I am not, this IC is used to difficult in LCD projects, so I not use this. I directly show you without this. So this is a 4-digit 7 display which has connected to Arduino, and this is an analog temperature sensor which are this one. This is a N-type and NTC round and pull down low round and 10 kilo voltage resistor as a voltage divider. That the other pin of this NTC to 5 volt of the Arduino, and middle pin is connecting the analog A0 of the Arduino of the ADC. Digital 2, 3, 4, 5, 6, 7, 8 are connected. This display 8, 9 or 10, 11, 12 are display. So here we connect 12, 11, 10 and 9 pin as a digit, use as a digit pins, meaning 9 is digit 1, 10 is digit 2 and 11 is digit 3, 12 is digit 4, and this is a common anode display, 4 digit 7 display. So there are 4 anodes, 7 cathode. 4 anodes is connected simultaneously between 9 to digital 9 to 10, and all the segments, all the digits contain 7 segments. So all the segments, A terminal is common, all the segments B terminal is common, C common, D common, and E common, and F common, and G also common to the others. So there are some 7 pins which are connected A to. Let me maybe later explain with software, but like now just demo this in here. A is connected digital 2, B is connected digital 3, C is connected digital 4, digital 5, digital 6, which are connected C, D, E, and F is connected 7, digital, and G is connected digital 8, and DP, which is decimal pin, which is connected digital 1. And digit 1 pin is connected 12, digit 2 pin is connected 11, and digit 3 pin is connected 10, and digit 4 pin is connected 9. And this time, what is ABC segments? I already explained in my one previous video, which video I will show. Open the multi-voltmeter, digital voltmeter, and I explained how 7 segment is what. Full 7 segment information available in. You can see my previous video, voltmeter video, then you can realize how this works. Now later explain at all, but show in here. And now this is an like mystery. Give it to me. Now we can turn on a matchstick and eat this thermocouple. You can use soldering iron as well as, I think it is too much. Yes. I know in the winter season it will turn on room heat in my room, so that's why it already show 430 to 30 something like that, 4.43 Celsius. Now lit the matchstick, and same time we eat the thermistor, and you can see temperature will be increasing 790 or 880 somewhere, and matchstick will extinguish and temperature goes below down. Now it's cooled down. Let me, I hold like that, both in his camera, keep away from table because I fired this even by heat. This is a heat sensor, not a fire sensor, so that's why if you fire it, it will burn. So I will give heat only, not a fire this time. temperature is 518. Now see, all these cameras to shake a little bit because I hold the camera, and you can see temperature of though 8 and something, still eating, and now come down and now once explain buying again, and then sensors. This time sensor is 5 volt. I am connecting to the sensor VCC connect to the sensor. This time sensor is analog sensor, so I will connect the sensor 5 volt to Arduino down and Arduino 5 volt to sensor down. Sensor down to Arduino 5 volt, Arduino 5 volt to sensor down reversely, because we need to put, if I connect that way, it will decrease the value instead increasing the value. So I flip the positive and negative terminal, so it will increasing the value, not a decreasing. And same A to 2 to 8 digital 2 to 8 pin are using for segments, A to G, and the digital one is the decimal pin 9, 10, 11, 12 or digit pin, which are all the pin is digital pin, and it's a 4-digit display, 7 segment display. Now this is a total of 7 segment thermometer, analog thermometer. So there are int number is variable equals 0. So int on times is also variable. These are variable. Initially both are 0. Float variable, float x variable equals also 0 by default. Int time equals 4 by default. LCD segment pins 2 A, 3, B. Int pin C equals 4. Int pin D equals 5. Int pin E equals 6. Int pin F equals 7. Int pin G equals 8. Int pin decimal equals 1. So these are all the digital pins. Int digit 1 pin also the digital 12. Digit 2 pin is connected 11, digital 11. Digit 3 pin is connected 10, digital 10. Digit 4 pin is connected. Digit 4 pin is digital 9. Digital 9. And if scroll down, void choose factor num. So it will void choose digit factor num. So it will choose the void if function which choose the digit factor numbers. Digit factor number. Switch number num. So it will switching the number one by one. Also serial pin the number. Also pin serial choose the digit default state. These are conditions. Total 7 conditions. 9 conditions, which is each condition it will contain 7 digital bytes setup digital bytes. So first it will digital byte A to low, meaning late A to on. Digital byte B low, meaning B also on. Digital byte C I, meaning C is off. Digital byte D low, D also off. And digital byte E on by low, and digital byte F I, digital byte G low, digital byte DPI. So this is my segment, LED segment is common anode one, so separate cathode. So anode is those to pull up, and all the cathode are pulling one by one low to make a digit. So first stage only DP and F plus C or I, and other one is all is low. So it means this 3 is not on, this 3 is not on, other one is on. Similarly, this process, though same there, but this time A also low. The previous one, B also low. Digital white B also low. As previously, this time digital white C also low. Instead, previous stage it will I, this stage low, and other one is almost same. Only this stage E is high, previous position is low, previous stage, and same stage repeats. Only they are, I cannot read this all much, so it will one by one test, it will turn on the some segments and turn off the some segments. And second state, it will turn off first few segments and turn on second few segments, and third test, it will turn on off first and second also, both at the same time, turn on third segments, and other tests is it will turn on one segment, first row of segment and second row of first segment and third segment, while turn off second and fourth. Similarly, let's turn individual segment on and off to make a particular order, particular number. But that's why it's due to their common cathode or common anode also, so that's why you cannot turn on the 4 or 5 digits at 4 and 5, 3 or 4 or more than 2 digits with different numbers at same time, because all the digits are parallelly switched to that, joined together in case of multiplexing. So that's why it will randomly print the first digit A1, all the digits also print same word. In order to that change, if you change a second word, it will turn the first word off, also change. So that's why we can put a bit faster to shading high frequency blinking, so you cannot see your human eyes. It will shading too fast, and also it is not steadily within. LED is simultaneously blinking in very fast way, so human cannot see any blinking difference. Even camera and rod, that is a tint which is that's the test which is your silent segment. You print different digits at same time. So it is not the different digits printed at same time, but it will one by one print the one digit print one by one, but it printing too fast, so it will see just all the digits in turn on same time, but it is not. So there's speed up in digits, test one digital wide digit 1I, test 2 digital 2I, test 3 digital wide digit 3I, default digit wide digit 4I, digital digit 4I. There's a digit on and off number, and they wide decimal place digital wide pin DP low. So DP is all turn on the decimal point. There's wide 7 segment int integer numbers. So unsigned that threshold equals int number divided by 1000, and register tester as equals int number divided by another 10, unsigned tester tens equals int number 10 and unsigned once equals int number integer number 10. First it will say if any number it sees, if you let me if you see if any number with Latin of this by default is less than 1000, it will start the function which is here. Let me this one. So in 1000, if 1000 greater than 0, meaning if 1000 is more than 0, meaning 1000 contain 3 zeros, which is more than 1 0, choose digit 1000, pick 1. So it will turn on the first digit. Also, if the second is, if that in value by random, it will pick up any value, internal random value, which value is divided by under, so it will come. For example, if we get 556 value, we can divide. If you divide 556 to under, you can get 5.6, which later modulate with 10, we that 5, which comes in the air. And same thing, if we do there under is under, if under is greater than 0, 1000 greater than 0, digit choose 2. So in this case 1000 is contain 3 zeros, which is more than single zero. Under also contain 2 0, which is more than 1 0. So that's why it will fit into digit 2. If same thing, if 10 is greater than 0, meaning 10 contain 1 0, it is greater than 0, and another also greater than 0, because another contain 2 zeros, and which is greater than single 0. 1000 also contain 3 zeros, which is greater than 0. It will put decimal, decimal, and it's not a decimal, digit 3. Now we can explain the code of this for the byte setup. Baud rate 9066 for serial communication, digit 1 output, digit 2 output, digit 3 output pin mode, digit 4 output pin mode, digit A output pin mode, B output pin mode, C output, and pin mode D output, and so on to DP. All these pin are outputs, so there is no input. N time is 0 by default. N time, which is a variable time, variable wide loop, float, sensor value equals map, and map the analog, map A0 0 to 123 1023,000. So meaning it will read the analog map, the analog 0, the analog pin 0 to 123, 1023. If that any value between, it will go further, but there with 1000 we set a 1000 value, which is a default value, which I of NTC temperature. So already I modified this code, so that's why it will say 3000, but NTC temperature sensor is at 1000 range. So I will set the map 0 to 1023. If there any value between this, it will go here, which is n time equals n time So n time is initially 0. It will add the 1 by 1 number into n time, which is a variable, add 1 by 1 until it will, this store is extra. It will not use in there, so we double slash to block. See up in the sensor value. This store is quite extra, or it will not work in. I will block them by adding double slash in. So you cannot read this store. If you read this store, it still be working. See up in sensor value. See up in sensor value, which is the two line 7 segments sensor value delay time. So it will 7 segments type the sensor value, print the sensor value into a 7 segment, and that means I can this slash plus hash store all the extra store. We can delete this store. So because this store is not working, we can block this store part, so we cannot, it is extra, so we can remove that because it is not used in this project. So it is for working for some other, this is changes from some other things of projects, so which I can, other type of modification which I cannot do this project, so we cannot use this. So this is a real code which I used in my video description, and if you don't have some next, you can pause.